Hello, everyone. Hello, good afternoon, participants. We will start our session. Okay.
Good afternoon, sir.
Yes, good afternoon, all.
Participants, please mute yourself. I request all to mute yourself, please. Oh, I can.
I think everyone is settled, so we will start our session on time because we have a lot to show. Okay, so I'll just wrap up my session of the sliding and giving the portfolio about the IndiaSoft in next few minutes. Okay, and we will start our technical session from in next 7 to 8 minutes. So today is a one-day webinar on circuit design, modeling, and simulation analysis for electrical engineering curriculum. Subjects like power systems, renewable energy, smart grids, switchgear protection using Neplan software. Okay. So basically, I will give you the IndiaSoft portfolio first in brief. So IndiaSoft technologies are from 1993, established in 1993. We are specialized in educational software products and services to private as well as in the government. Okay, so we have in previously we dealt with the simulation softwares such as like a MATLAB, Simulink, and SolidWorks and AutoCAD, and in the such as processor, electrical piping and casting and etc. Okay, so we have a world standard engineering simulation software for educational. First is the Automation Studio for hydraulics, pneumatics, PLC, mechatronics, and electrical. This is first for the from the mechanical portfolio. Then another one is a CNC simulator, CNC multimedia teachware, a CNC machine and control panel simulation. Then also we have a Siemens Solid Edge and Solid Edge Cam Pro for turning, milling, 3D, multi-axis. And then we have a Witness for process and factory modeling, simulation and optimization, and then FMS system and simulation. Then also we have a Pro Simulator and Unisim for the power plant and as well as for the process simulator. Then we have a Real Arc Welding Simulator, which is a virtual welding simulation chaos system. Then we have a Flownex for thermodynamics, heat transfer, rack, and fluid dynamics. Then we have a electrical software, which is our today's hero. This is Neplan for the electrical power system simulation software. And then we have for the power electronics, the CASPOC software, which is address the electrical machines and as well as the electrical machine and drive simulation. Then we are not in just providing the software. Okay. From last 25 years, we are giving the solution vending to the many institutes like IITs, NITs. We have quietly done a job in the TechWhip institutes also, and as well as the state private universities. So we are not believing in just two relationship with the only for the software. So we establishing the experts lab also. These are not just expert labs. These are greater than the even from the COE also. Okay, and these many portions we are addressing in the expert labs. First is the industrial fluid power lab, mechatronics, automation, robotics, the second one, electrical power system and analysis, power electronics, electrical machines, electrical drives, renewable energy, power plant, electronics and PCB fabrication, and welding turnkey lab also. Okay, then these of our portfolio, which is we have done our work in the government institute. You can see as a MSME tool rooms, DT Maharashtra even, DVT Maharashtra, HL Training Academy Ozar Nashik, and some of the TechWhip World Bank projects from TechWhip first, second, and third projects. We have given our robotics lab in the CET Bhubaneswar, UCT Bikaner. We have given our digital lab. Even recently, we have given some softwares in the PMSC Odisha also. So this is some history about the Hitachi and ABB. It is actually start from the 1988, were formed during the Europe's industrial revolution after the introducing electrical power transmission, rail and industrial technologies. These two pioneering brands merged in 1988 to create ABB. So according to these decades, ABB and Neplan is working in this domain. So Neplan is also founded in 1988 and developed as a high quality software for electrical, gas, water, and district heating networks, as well as specialized services related to these fields. Okay, so you will in next 1.5 hours, you will see the brief about the Hitachi ABB and Neplan also. Okay, so moving on the next, we have some electrical labs, expert training center as previously I told you, electrical power systems and analysis, power electronics, electrical machine and drives. Okay, so we have done 3 sections in that. electrical expert training. The first one is the electrical power and renewable energy. Another one is the AC/DC machine, and the last one is the electrical drives, power electronics, and AC/DC machine. So here you can see we can give you the power plant and power renewable energy lab. So where you can have a full scope power plant simulator, industry emulators of Honeywell and Yokogawa. Okay, and this is this type of you can see in the second image. This is the smart grid system with the SCADA integration. Okay, and in the bottom you can see also the standalone system for the wind, solar, fuel cell, and etc. We can give you the smart grid technology with SCADA and without SCADA. If someone wants to be standalone system like a transmission, distribution, and generation, that also we can give it to you. Then this is the full scope OTS simulator with DCS emulation with the full scope high fidelity power plant simulation models, power on processes, basic processes, instrumentation processes, and the electrical transmission distribution smart power grid. Okay, so this type of hardwares also you can see. These types of hardware also you can see. Solar, wind, hydrogen, fuel cell, smart systems, transmission, distribution. So these types of all we can give it to you in the hardware. Okay. Another one in the whole huge list in the power system trainers in the hardware also. This is smart grid trainer system with SCADA. Then this is real-time model-driven SCADA OTS system, smart microgrid training system interface. Yes. Along with that, we also provide the HVDC and FACT systems also. This is also our electrical machine and power electronics drives laboratory. So these types of modules also we can give it to in the electrical machines lab. So here you can see the this is a one video of a high-end simulator. Just 1 minute, it will play. This type of you can see now you're on screen. It's a smart grid SCADA system. Please play. Where is PPT? This one is PPT. This one. Go to the. Yes. प्रोजेक्टर पे दिखता है वो अक्षर दूसरों को नहीं दिख रहा था गूगल मीट में वीडियो नहीं दिख रहा है प्रोजेक्टर पे दिख रहा था क्यों यहाँ पे सर्वर रहता है Thank you. So this type of smart grid system we can establish in your college, okay, as you have seen in the video. So the next video you will see the electrical machines lab. So these types of electrical machines hardware also we can give you in the lab. Okay, that's it from my side. If you have any hardware regarding query or any software regarding query, this is my mail ID shiv@indiasoft.co.in. You can contact me on. And now I would like to request to Trinath sir to take the session and please show us the Neplan, all the features.
Yeah, thank you, Shiv. Am I audible to everyone? I hope my voice is audible. Hello?
Yes, sir.
Yeah, thank you.
Yes, it's
So this is,
audible.
I'm Srinath, the principal consultant working for Hitachi ABB Power Consulting. So I, we at Power Consulting Hitachi, we believe in in working on the industry university relationship because ours is a knowledge based work. We work on power system analysis for the industries and transmission systems day in and day out using various power system analysis softwares. So we always believe that the academia is the backbone for all the innovations that are happening and that shape the future of the industry. So as part of that, we have been participating along with the academia in the power system analysis software developments from long time, so since 1990s. And many of the institutes within India, we have given this Neplan power system analysis software to universities like IIT Kanpur and Banaras Hindu University, and many of the utilities and some more private engineering colleges also we have given this, and many of the utilities in India like GETCO, Maharashtra Energy Regulatory Commission, the NP National Power Training Institute, all of them
Hello?
they use this.
Sir, you have
Hello.
to present your screen. There is a bottom in the.
Actually, no, that's okay. I have to join from the mobile. The main presentation content will be taken by my colleague, Mr. Panos. So I'm just
Okay.
just giving a general introduction of the software.
Okay. Okay. No problem, sir. Go ahead.
Okay.
Sorry to
Yeah.
disturb you, sir.
Yeah.
Okay.
Yeah. Not an issue. So at Hitachi, recently we got merged with Hitachi. So the expanding our portfolio of services, right from power consulting services to the Internet of Things in the power system. So this change happened in the 2019 year. So as I was telling, so the number of training institutes like NPTI and CPRI, these institutes have this Neplan software used for various analysis, and the user friendliness of it has been appreciated by a lot of these members. And now we take this opportunity to share with all the faculty members who are pioneering the innovation in the area of power system analysis and research to how best they can utilize this kind of softwares to teach the students how the power system is going to work and how the concept can be better induced through the software with the help of the software. So I request my colleague Mr. Panos, he's from Neplan, Switzerland. So have we are he is present. He is going to present you with all the features of Neplan and what are the different things that you can do using an analysis software, and how the teaching can be enhanced using these softwares. Yes, Mr. Prasad will try to present tell the distinguishing features, but then it is not like it is compared to a particular software. We would like to put the things in a way where how better these things can be utilized and how easy it will be for the faculty or the students to follow for the different kind of analysis without having much complexity of databases and all. So, Panos, I request
Yes,
you to please proceed with the things.
thank you.
Thank you
Thank
very
you very
much.
much, Brilliant. Good afternoon, everyone from Switzerland. I'm representing my company, Neplan. We are based in Switzerland, and I'm going to make the presentation for Neplan. Basically, I will make a small presentation, 30 minutes. I will try to compress a lot of information in 30 minutes, but trying to convey the message that what you can do with the software, with Neplan, and then with whatever time is remaining, I can make a live demo. So let's start with the presentation. Can you all see my screen?
Panos, I think it's not visible yet.
No, sir. No, sir.
Okay, let me try to share again. Just 1 second.
Yes, I think the desktop is visible now.
This is not my desktop. Probably I maybe Maybe the
Shiv?
previous presenter should stop sharing.
Shiv, I think you have to make a panels the presenter since you are the organizer of the meeting.
I have requested to share, but probably you cannot see my screen. Okay, let me try now. Can you see now my screen?
It's
Yes, sir. Now it is.
yes, yes, it is visible.
Okay, okay. So, what I'm going to present Neplan as for the electrical part. Of course, Neplan has also gas, water, and district heating networks. My name is Panagiotis Kontodimos. I'm senior engineer in Neplan. I started as developer especially for steady state, like load flow and optimal power flow calculations. Then I passed and I made other studies, and I made also development in other features, let's say, of Neplan. And now what I'm doing, usually I make trainings, I'm making a delegation for Neplan, and I represent the company in tenders and in competitions. Anyway, let's start with software, which is for design, planning, optimization, operation, maintenance, and research. By the way, I have assisted numerous of research projects and students, PhD, undergraduate students in different universities all over the world, working with software Neplan. Of course, Neplan is not only for research; it's also for industry. And we have references all over the world. Okay, let's start with a presentation. The company is present in more than 110 countries worldwide. Transmission companies in Europe, Central, South America, Africa, India, DSOs as well. Industrial companies like, for example, generation networks, gas, oil, mines, steel, chemical, car manufacturers, wherever power networks need to be simulated and studied and make planning. Engineering consulting companies and departments, universities and research institutes worldwide. We have a highly competitive and skilled staff with a majority of our colleagues holding PhD and master degrees and huge experience and know-how since 1988. This is, of course, what we are doing. We're doing only software, and we are doing only software development and maintenance. So we have a very specialized, let's say, niche on this matter. Products and services. Of course, we have a product range, starting with Neplan, which is for network analysis software for transmission, distribution, and industrial electrical networks, as well as gas, water, and district heating networks. Now we are focusing only on the electrical part. But we have also some other products which we are not going to address right now, like, for example, the asset management, which is for infrastructure asset management, especially in the electrical domain. We are offering the software as calculation engines for OM integration for our third-party systems. For example, it can be a SCADA system where they want to integrate our calculation algorithms in the SCADA to make some calculation on the fly, let's say. GIS providers, they want to increase the power of the GIS by integrating calculations such as power flow, short circuit, or other calculations, and so on. And we have also some other modules which I'm going to skip right now to go into the more, let's say, interesting parts. Study services and consulting. Of course, we are not a consulting company. We are doing only the software, but of course we cooperate with consulting companies around the world, and we exchange know-how on studies and different projects that came that are existing, let's say. So what we can offer, what we can help for network modeling when we start, and we need to model the whole network, and we have the know-how, and we can assist on this. For data migration, when we have already some old software or software that we don't want to use anymore, and we want to bring all the information, all the databases and the models in Neplan. And here are some examples of studies that I'm talking about. For example, integration of renewable energies, for e-mobility, hosting capacity of networks, reliability calculations to assess SAIFI, SAIDI, network reliability indexes and load point reliability indexes, dynamic stability, transit stability, but also dynamic in general, dynamic simulations in general, protection coordination for whenever we have a protection schemes, let's say, that we want to coordinate, whether it is overcurrent protection exclusively, or we have distance protection relays and we want to coordinate them with overcurrent. With Neplan, you can do a full protection calculation for electrical networks using overcurrent relays, circuit breakers, and so on from the library. What we are also doing, we are doing custom software development. When we have customers, big utilities or third-party software manufacturers, and when they want to make something custom that does not exist out of the box or from Neplan, then we can also work for this and develop custom software development. Or if there is a new calculation that is required from a customer of us, then we can develop this for the customer only. And we are also offering trainings, training courses on power system analysis and Neplan in particular, workshop all over the world, and we hold annual user meetings in designated locations. Now let's see a little bit about the software architecture. Of course, the company started in 1988. At that time, we had Pascal. Pascal programming language was the software was the programming language for the software. Of course, now time passed. We have now version 10/360. This is the same software. 360 stands for cloud, so that the software can be accessed throughout. There is no need for any installation; can be accessed with through the cloud. And now, of course, this version was developed with C# programming language, and we are talking about 64-bit. I'm going quickly here for the installation for intranet, especially for research institutes, for universities. What we are offering is this intranet installation, where the software is installed in a server, and then all the researchers or students, they have access to the software through the LAN. All the calculations are performed in the server. And these are the clients where they can see the results. They can load, let's say, the networks and so on, and then they can run the calculations. The processing power is on the server where the calculations are performed, and then we send back the results, which can be viewed from the client. Let's say when we run a load flow, then we can see our results here. I'm not going to go into details on the installation and the technologies. For example, it is required that we have SQL database in the server and so on. I'm not going to go into these details because I want to go into the calculation section where we can see the calculation modules. Here I have some software features which also I'm going to pass very quickly. I just want to tell you that in Neplan we have map integration. That means that maps are integrated in the software. It's not like a static picture. It's a real map server which is being used, and then we can see the network in overlaid from, let's say, from a GIS. We can directly see the network with a geographical information, anatomically correct. At the same time, we can have a schematic representation, which can be automatically generated from geographical networks. And we have also ability to load the network partially. For example, maybe we have a huge network for a whole country, but we are not really interested for a certain study to have the whole network. We can select only a substation or an area, and then we can load only this area. So we have this map integration and map separation. We can split, let's say, the network for easier handling. Of course, this is particularly interesting for distribution networks. For transmission networks, this is not so much the case working with the maps. But anyway, Neplan is for distribution and both for transmission and distribution, and also for industrial networks. Of course, what you can do with Neplan is you can make the so-called versioning. You start from a base case, from a scenario, let's say, from a base scenario, and then you can make different scenarios. Let's say you can add the capacitor, or you can add the transformer, or you can add you can make a load shedding, and then you can see results for every scenario that you have done, and then you can progress building a tree, let's say, with different approaches. This is, of course, for planning. When we start with our today network, and then we want to see in the planning, let's say, phase, what is going to, which strategy or which reinforcement or which enhancement is the best to get, let's say, from the simulations, the best results, whether we are making optimization, whether we are trying to tackle a technical issue, violations, or whatever the case may be. Now, about the results, of course, we have many possibilities to view the results. We have the possibilities to view the results with tables. Like you see here, I can see the result for every item, for every equipment, for every two-winding transformer, for every line. I can see the actual power, reactive power, current, loading, losses, and so on. We can see the results in visualization, which I'm going to show you later on. We can have customized reports like we have here with BESCOM. We can have pie charts in the single line diagram and so on. Of course, we have other possibilities, like we can make heat maps, and we can see immediately in the network where we have a problem. By looking at the heat map, I can see immediately where low voltage areas are in the network. I can see across the feeder where how the voltage profile is across the feeder, and if I add, for example, a shunt capacitor, how this profile can be improved, and so on. Again, here I have many possibilities for result visualization. Here I visualize voltages in percentage, and then immediately I can see where are low voltages and where are high voltages, and here I visualize loading in percentage, and I see that certain areas are overloaded, let's say. Now, let's go in the calculation modules. Of course, for the calculations, we have many modules. In our given time, we don't have time to go through all of these, but I can tell you what are, of course, the research package that we provide includes all modules. And this is very interesting for research and for universities, because then in research you can really do advanced stuff with this. And in the end, I will also show you the scripting where you can program your own API interacting with Neplan. Anyway, for the calculations, of course, the basis of almost any software of this type is the load flow, the power flow. Then we have also the security, the N-1 analysis. We have also a load estimator based on measurements. This means that we can make the load flow also in time, with time, let's say, simulation. Then we have short circuit fault analysis for simulating single phase to ground, three-phase short circuit faults, open conductor faults, and so on. In the load flow, I have to mention also that it supports three-phase symmetrical load flow, but we can also make load flow for asymmetrical networks, whether the asymmetries are on the load side, having, for example, loads with a single phase or a two-phase loads, or if we have asymmetrical lines, let's say, where the impedances are not distributed equally on the power line. Then we have also some modules for industrial, let's say, use, like a motor starting, where we can simulate in an industrial installation how the motors are reacting during the startup, and let's say we can set the time frame to make a simulation for the first 10 seconds or 20 seconds to evaluate the cable strength and so on. We have line parameters calculation by providing the geometrical aspects of pylons and the lines and distances. We can make the calculation of impedances. There are plenty of modules here that I could talk one day just for one of these modules. Unfortunately, our time is limited. Net transfer capacity, where we can estimate from one area to the other how much power can be transferred. This is for transmission. As you can see here, we could make a distinction between some modules are more relevant for transmission, like the net transfer capacity. Some modules are more relevant for industrial, like, for example, the motor starting. Neplan software comes in a modular fashion, let's say, which means that somebody can order the software and he can have only the basics like load flow, short circuit, and dynamic analysis, and then he can add on modules. Continuing, we have modules for protection, like overcurrent protection, with a huge library from all the commercial protection devices, distance protection for transmission distance protection, and some advanced protection schemes. And then we have optimization modules, like, for example, optimal capacitor placement, optimal separation points or switching optimization, investment analysis with the net present value of investment. We have hosting capacity calculation, where we evaluate how much power can be supported from a specific network. N-1 constrained optimal power flow and optimal power flow. Reliability calculation, very advanced reliability, where we can see load point reliability indexes, like, for example, frequency of failure or repair time, and we can see also network reliability indexes like SAIFI, SAIDI, and we can see how we can improve them. Then we have power quality modules, like, for example, okay, I mentioned reliability, harmonic analysis, flicker analysis, and the dynamic simulator, which makes the simulation in time using differential equations, because, for example, load flow is a steady state calculation. The formulation of load flow is using the steady state P and Q quantities. But when we are talking about phenomena that happening, let's say, in milliseconds, then we cannot use load flow. We need to use dynamic analysis, because then the system is modeled, let's say, with differential equations internally. For the user, it's very user friendly, and then we can make the more detailed analysis, let's say, for transient, even for EMT. But the strong point is more for the transient phenomena, not the super fast, but the very fast, let's say millisecond to second. For example, we lose a power line, or we have a fault, and we want to see how the system reacts in the next 5 seconds, whether the system will keep being in synchronization, or we will have a cascading effect where we will have maybe a voltage collapse, or we will lose some generators due to desynchronization. For interfaces, here I will not mention much. I will only mention in the end about the API programming library. There are also other modules, like the investment analysis, for example, where we make different scenarios and then we calculate the net present value of each scenario to make some economical evaluation. For gas, water, and district heating, and then the Neplan asset management. Here I will also skip it because I want to concentrate more on the electrical part. Starting from load flow analysis, which is the fundamental, as I mentioned, suitable algorithms for transmission, distribution, generation, industrial networks. There are different methods that can be used, like Newton-Raphson, current iteration, and back-forward sweep method. We can have any combination of single-phase, two-phase, three-phase, AC and DC networks. As mentioned, symmetrical and asymmetrical networks can be handled, also 5-wire systems. About controllers, all types of network controls, like, for example, voltage regulators, phase shifters, remote controls, multiple slacks, generator Q limits, all kinds of controls can be are included. And of course, we develop the software all the time. If there are new things coming up, especially for smart grids, and we integrate them. Facts, where we can simulate models. We have models for SVC, TCSC, and rest of facts. Models for smart grid and renewables. This is particularly interesting for the dynamic simulation, where we have specialized controllers, let's say for wind controllers, the turbine controllers, or we have, let's say, detailed photovoltaic inverter controllers, where we can make really very detailed simulations. Of course, we have to know what is our task, let's say, when we are doing, because very often what we need is a simplified steady-state modules when we are interested about energy calculations, for example. But when we are making a research for a system, for a microgrid, probably, then we need to go into more details regarding the controllers and the hardware and how we can simulate this. Here is an example for load flow analysis, where we can make the heat map, and we can see in the network the heat map. We can also see results with the bars. For example, here are countries in the interconnected European network, and I can see, for example, France and Germany, they have the highest losses among the European countries. And I can see the results per feeder. I have here feeders, and I can see my results and their feeder profiles. Then another, which is important and very interesting, especially for research, is the load flow time simulation. Load flow time simulation means that we can have profiles for certain consumers, whether it is, for example, a household, industrial, and we have profiles in time, or we can have real world measurements from a smart meter, or from, let's say this is for a PV, and then we can integrate these measurements and we can make the simulation in time. Of course, this is not to be confused with a dynamic simulation. This is load flow time simulation. And then we can see the aggregated results in time. So we can make, for example, for 1 month or for 1 week, we can see how our system reacts. And this is, for example, an idea is, let's say we have electric vehicles which are charging and discharging throughout the day. And then we want to see a weekly profile, how this is affecting the network, let's say, because we can see, look, for example, at 8 o'clock in the evening, we have some violations due to electric vehicle charging. Then what can we do? Can we make some load side management and so on? Fault analysis, very old calculation and mature calculation. We can make all kinds of fault, 3-phase, single-phase, 2-phase, with several calculation methods, like the IC, ANSI superposition method, and we can see the results. Again, we can see the results directly on the faulted location. We can see the results using reports and so on. We have provision, of course, for new components when we have, for example, converters. Like, for example, we have a machine which is feeding the network through a converter. Then we can simulate if there is contribution from the converter. Then we can model this and we can simulate it. Of course, here we follow the the standards. This is defined, for example, in IEC standard. The point here is that we constantly integrating the new, let's say, the new technologies into the calculation. Here is an example when we have a passive wind power, for example, feeding directly through a transformer, and then a PV through an inverter to the network. And then the modeling approach when we are making the fault analysis is different. Power quality, as mentioned, about harmonic analysis, we can make a harmonic load flow. This means load flow on specific harmonics, fifth harmonics. We can calculate total harmonic distortion for voltage, for current. Again, we can simulate any kind of networks, and we can make the harmonic sources as we can model them as current sources, voltage sources, and of course there are libraries for harmonic sources. We can study, for example, resonance in a network when we have. We can make filter designing. By looking, for example, if connecting a filter, we are able to reduce the total harmonic distortion and so on. Flicker calculation, when we have flicker problems because we are near an industrial connection where they have some huge machines affecting the voltage, let's say, quality, and we observe flicker, then we can make the flicker calculation and we can see ways on how we can improve the flicker. Reliability, as mentioned before, reliability is huge calculation by itself. We can make the calculation for the whole network, calculating the index reliability indexes. We can make, for example, we can make calculations for industrial applications, industrial networks, when we want to estimate reliability for load point indexes. Here, there are many things to say about reliability, but I'm going very quickly. Okay, here's a representative example with ABB Germany, where we had the configuration of the network, and then it was another configuration was proposed, which was simpler. And by this simpler configuration, they were able to save a lot of money. But we had to make a study for reliability to see if it was acceptable. And this is very, very important to have reliability module. Because, you know, reliability can be calculated from historical data, from SCADA, let's say. You can get all the information, all the measurements, and you can say, okay, I can calculate the reliability. Why I need Neplan for? You need Neplan for because if you want to make configurations in your network, you don't know how this is going to affect your network unless you're making a reliability calculation. That's why and this is where Neplan reliability module comes. Anyway, the outcome for this case, for this study, it was that the reliability was a little bit worse, but still acceptable, and they were able to implement it. Then we have the Neplan dynamic simulator, as mentioned before, very advanced for dynamic simulations, for transient stability, for faults, let's say, for PSS tuning, for AVR, for controller design, and so on. The model definition here, of course, what we have, we have the network model, as we saw before, with power lines, with generators, with loads. To run a dynamic simulator, we need more data, and this data can be entered in an easy and user-friendly way. For example, inertia of the synchronous machine. When we're running a load flow, we don't care about inertia, but when we are running a dynamic simulation, we need inertia, and Neplan has the way, has the functionality to inform the user what data are missing when he's trying to make a calculations, and some data are missing. And what we also need for dynamic very often is the controller. So if we have a synchronous machine for the load flow calculation, I don't need to know what is the AVR controller transfer function, or if we have power system stabilizer, or if we have turbine control, which controls the let's say if we have a hydro generator, how the turbine is opening or closing the water flow, for example. But when we are doing a dynamic simulator, we need this information, and we have a very user-friendly way to include all this information. We can make the controller model with block diagrams, but we can use some, like we have in Simulink, or we can use macros to define, let's say, the controllers using the like the differential, like equations, let's say. I go fast here. I'm just showing you here a case where we have the whole European interconnected transmission network, and then there was a study. Let's say we want to see how the network reacts if we disconnect a country, let's say Spain. We have a blackout in Spain, and we want to see if the rest of Europe is going to maintain the function, the synchronization. And this is the results, let's say, of the study. We are talking here about a network with 21,000 nodes. Of course, this size is not a big network; it's just a medium-sized network, let's say. And this is what I was saying about the controllers. You see, if we are running a load flow, we only need to say the P and the Q or the P and the V of the machine. But when we are running a dynamic simulator, we need also to model the controller. In Neplan, we have a huge number of controllers which can be used. They are pre-installed already, and the user just selects the controller. Of course, you can see the transfer function, the block diagram of the controller with the different transfer functions, and then you can select. You can see, okay, this controller is not making good work for my control. Then I can use another one, or you can request for an existing installation. You can request to get the actual controller model and then simulate it in a very accurate way inside Neplan. Of course, if your controller is not existing in the predefined controllers, you can build your controller like in Simulink with the blocks, which can be connected in any way that is suitable to have your own controller model, let's say. And there is also another possibility for making these controllers using SimDef. This is let's say macro, so with equation described. Let's say this, we can describe the whole thing with equations. For every possibility, there are pros and cons. That's why we have different ways for modeling a controller when we want to make a dynamic analysis. The dynamic analysis, the simulator, of course, like always, we have the parameters. Like, for example, I want to make a 10-second simulation. There are some other parameters which the user learns to play with them. Usually, we don't change them very much. Important is the ending time. And what is important is the events, that the user can go and specify events. So what is an event? Event is, for example, a three-phase short circuit at time 0.5, and then clearing the short circuit at time 0.7. And this is a disturbance in the system, this short circuit, although it is cleared. Then what we want to see is we want to see different plots, different charts, and then we see our results of the dynamic simulator. So you see here at this point is my fault, my short circuit, and then it's cleared after some time, but still the system has to find again the stable point. Otherwise, it can be that we have not stability in the system, but it's instability. There are some other modules, for example, connection assessment. I go quickly here because this is more related to some standards, especially in the European countries, when they want to connect, for example, a new photovoltaic, or when they want to connect a new industrial customer. Then the utility has to assess if this connection is okay in terms of some criteria. And these criteria are well defined. So, for example, we can make a quick assessment for flicker, voltage rise, harmonics, overall assessment. And this is offered as a module for quick assessment. But of course, all of these can be done one by one. Anyway, this is the connection assessment as a module. For transmission now, we have different modules. Especially interesting is the contingency analysis N-1, where we specify the outages, and then we can make the ranking of the outages, and then we can see, okay, if we lose, for example, this line, I can see that I have violation in my system, so therefore my network is not N-1 secure, and then I can study ways on how I can make the network secure and study different scenarios. Optimal power flow, we have a current settings and dispatch of a network, and then by using optimal power flow, Neplan is able to suggest a different dispatch where we eliminate any violations, and at the same time we optimize the network according to an objective function, whether it is generation cost, whether it is losses, active power losses, or other objective functions. Here, for example, you can see that before optimization, we have some violations, and we have generation cost at 11,000 euro per hour. But after the optimization, the software is able to propose a dispatch scenario for the generators where we make we make a generation with 6.7, and at the same time we eliminate all violations. Again, this is a case study where we have here a load sender, and we have thermal units around the city, and then far away it was a hydro dam here and here, and then it was a case where they wanted to find out if they can maximize the hydro generation and what is the maximum output of the hydro generation that should not undermine the operation of the network. And this can be found with the optimal power flow by making optimization. The algorithm is obliged to find a solution, the cheapest solution, which is not violating any constraints, let's say, loading or voltages. Then we have area control when we have, for example, cross-country contracts where we have a contract from one area or to another area. I don't know if in India there are also such transfers between states, but anyway, it can be, if we have the model of the network and we have the model split in zones or areas, we can fix the load flow from a specific tie element in a certain power. Because if you run the load flow, then this power will be dominated by the physical laws. But if there is, for example, a contract, if there is a controller, then we can fix the power between different zones or areas. Network transfer capacity, where we can see the maximum power from one state to the other state without violating any margins. Power transfer distribution factors. This is for sensitivity to see for specific transactions how the power is distributed among the rest of the network. Voltage stability, where we can make a full calculation for voltage stability. A popular method is to make the voltage stabilities using the VQ curves and the PV curves to see how the system reacts and see what is the point where we have voltage collapse. There we can make different kind of sensitivity analysis, so we can see, look, this bus bar, for example, this node is mainly responsible for the voltage instability, and then we have a shorting, and then we can see, okay, this doesn't participate in the voltage stability. Therefore, we need to concentrate to these bus bars in order to improve voltage stability, as an example. Okay, here is some examples with the results that we are getting. Small signal stability, where we can make the plot in the root locus, let's say, we can see with the scanning how we are going towards instability. Here is stability, and the right part is instability. And you see, like when we increase the power, slowly we are going towards instability, and then we can see it in a visual way with eigenvalues. This is particularly interesting when we are making, for example, PSS tuning, and we want to tune our PSS in order to bring all the zeros and poles in a stable, let's say, in the stable area. HVDC technologies, we can model HVDC systems using classical thyristor-based converters from AC DC, DC link, and then DC to AC. Or we can use the modern approach with PWMs, and then we can also have multi-terminal HVDC link. So you see, this is the link, and then we have an infeed from this part, infeed from that part, and then we have here the other side of the network. Now for distribution, we have also several modules for optimization. For example, we have a network, and we want to find out, as you see, this network is meshed. The nature of the network is meshed, but it is operated radially, because you see here, these are the open points, and these are the initial open points. But very often in utilities, we need to know if there are open points, if we can make the switching in a different way to keep the radial operation, but at the same time improve the network in terms of losses, let's say. And this is optimal separation point, which is able to suggest the switching of the network in order to improve the losses, let's say. And this is a representative example with a small part of the network. This is a real network. This was the initial configuration. And then this is the configuration after Neplan calculated it. As you see, for example, the yellow is much less extended here. And by doing this, just by switching, we are able to save $140,000 on an annual basis. And this represents 5% of the total network. So for the whole network, we are able to save $2.8 million US dollars just by making different switching of the switches. So with no investment cost, we are able to save 2.8 million in the losses. Optimal capacitor placement. We have a network, and we would like to know where is the best location and what is the best size of capacitors to install. Then we can use optimal capacitor placement, and then the software will tell us exactly where we should install capacitors with a maximum influence, let's say, in other words. And it's doing also some economical evaluation of the capacitors, because sometimes, if, for example, losses are very cheap, if we are going to Saudi Arabia, probably for them it's better to pay for the losses because the energy is very cheap there, rather than spending money to install capacitors. So there is also an economical aspect in this, and this can be done with optimal capacitor placement. Other modules like optimal reconductoring, optimal circuit breaker placement, hosting capacity, where we can see for a network how much power can be connected, and then we can input also other variables, like, for example, surface available for the household, if we have this information. Otherwise, we can use some probability distribution. E-mobility, where we can make calculation automatically for every location, how much power can be connected when we want to connect, for example, new chargers on a specific location. We have all the time, every day, we have customers, every day they're making this calculation, and they know exactly for every day what is the power that can be connected. So immediately they can make the assessment if somebody wants to make a new charging station or a charging, let's say, he wants to connect a new charging for e-mobility. Okay, here are some other studies that have been done for e-mobility integration. They take the whole map and they use some simulations to check some probabilities about the e-mobility, taking some socioeconomical studies. Anyway, this is just a study, an example. And then for industrial, we have cable size, cable check, where we can make the sizing of the cables to meet certain criteria. Such as current rating, protection, protection against hazardous voltage, and protection against overheating. So the software is able to suggest you here the cable based on the load that you have in order to pass all these criteria. And there are standards for this, IEC, ANSI, DIN, and so on. Or in an existing industry, in an existing installation, we can see if our cable that we have, the cables that we have, are passing all the criteria. So we can say, look here, according to the cable check, the cables that we have are sufficient for these motoric loads, let's say. Arc flash, which is now more in fashion, more and more people, especially when they're making, for example, the cabinets, they want to make the categorization based on arc flash hazard, and this is what Neplan is doing. He's calculating the categories for arc flash. So for a certain location, if somebody has to enter this part of the facility, then he has to wear certain clothing because arc flash hazard maybe it's very high, and this is able to be calculated with the software. Now for protection, as mentioned, we can make the selectivity analysis and the protection coordination. We can see the selectivity chart. So if we have, for example, this part, we see that there is here maybe a fuse, a circuit breaker, overcurrent relay, and then we can see all the protection equipment, and we can make the settings, the protection settings directly on the selectivity chart to ensure that we have selectivity in our network. There is a huge list of a library that can be used. We have almost all protection devices in the industry, ABB, Siemens, Alstom, and so on, and the users can build also their own protection characteristics. Same is for distance protection, for transmission networks, where we have transmission lines, and we use the distance protection relays to make the distance protection coordination to ensure that the zones are well set in order to have selectivity, because there are some rules on how the settings and which relay should trip first according to the selectivity, let's say. Okay, here with protection data management system, I go quickly from here because this is more for in industry. But anyway, we have the possibility to see if the settings that we have are adequate by visualizing the results. And we have also the other kind of advanced protection features. This regards mainly the dynamic simulation. For example, we might have differential protection, busbar protection, generation protection, and so on. Fault location finding, where we have a fault and we can provide the measurements of the fault, let's say current and voltage, and then the software can estimate the location, the distance of the fault. So we can locate the faults easier, especially if we combine it with fault indicators in our network. And by closing, I just want to make some a remark about smart grid and renewables. In the past, PV and wind power plants were not integrated in a bulk way. Nowadays, we have more and more PV and wind, and therefore we have very often grid codes. The grid codes might concern active power control, reactive power control, dynamic network support, and grid management. For active power control, we offer for renewables, we offer different strategies. For example, when you model a PV, then we can say, okay, look, in my PV, I have a certain function, which is power factor as a function of active power, or power factor as a function of voltage. And then we can add this, and then during the simulation, this is kept, let's say, for the calculation. So as you see here, I have a photovoltaic, and I can say my type is power factor is a function of voltage, and then I can give my points, point by point. What is here is the voltage. If the voltage is 100%, then the power factor is 0.9. Not capacitive, inductive. And then if my voltage goes to 90, then my power factor is 0.9 capacitive. So it tries to maintain the voltage in a range, let's say. Apart from that, we can have fault right through here, for example, different countries in Europe, Italy, Germany, Denmark, and they give the rules on how the voltage should recover in case we have a fault. And very often we want to simulate this also in our simulation. And what we are doing, we are giving this information to the connection with the grid. Here is my installation, and here is my grid connection, and I provide him the fault right through. This is the rule on what I should try to comply with in case there is a fault. I give it point by point, and then I make the simulation, and I see, look, by using a certain controller, by using this controller, I am able to respect the fault right through rule that has been given to me from grid codes. This is a case calculated with a dynamic simulator, as we saw before. Now, for smart grids and batteries, we can make, for example, here it's charging and discharging. This is for dynamic simulator, going very much into the details of the charging controller. Sometimes what we care about smart grids and batteries is energy, let's say, calculation, and not the very fast phenomena. Then again, we can simulate. We can have here a battery. We can give measurements for the load. This is my load, the daily curve of the load. Here is the photovoltaic for 1 day. And then I can make different scenarios with different sizes of batteries. So you see this is with no battery. And you see this is the red part. The red part is showing what comes from the grid. But when I include batteries, then you see that the red part is very much reduced. This means that I make less interaction with the grid. So if this is a microgrid, I can minimize the interaction with the grid, so I can make more efficient use of my local resources, and I don't need to request power from the grid just by adding storage, let's say. Same thing as I showed before with inverter control, this is power factor with a function of power or voltage. For wind turbines, we have all the models, especially those IEC models, which are very the popular WT1 to 4. 3 to 4 are the most complete models, where they include all the parameters for a wind park. This is my wind generators. These are all the controllers. Maybe I can include wind data and so on, and then I can make really detailed calculations, and I can see how my wind generator will react in case I have a fault. And finally, I would like to make a slide with web services, and this is the scripting that I mentioned before. I understand that, of course, we have Neplan, which is a software, commercial software, and you don't have access to the calculations inside. I mean, you cannot make changes in the load flow, how it is. But what you can do is you can write your own API, your own software. The researcher can make his own software program, for example, in C#. And what he is able to do via web services, he's able to command Neplan. So if, for example, you want to run a load flow in your own application, you don't have to reinvent load flow. You just need to give the command to Neplan. Neplan will make the load flow, and then it will give you back the results. And then you can build your algorithm, let's say. Maybe you want to model, you have a new methodology where you want to evaluate what happens. You want to make a Monte Carlo, let's say, a simulation. And then you want to run different many load flow calculations with different scenarios. Then this is how you can do it. You can do it in a programming language, loops, and so on. And via web services, you have access to all the calculations. A condition, of course, is that the network is modeled in Neplan, and then you can make the calculations, and then you can get the results for every calculation back. So this was a short presentation for Neplan, and we can go and see now the software in a live demo. I don't know if you have questions so far about the presentation.
Very short.
Go ahead, sir. Go ahead.
Actually,
Pardon?
I said go ahead. Go ahead with the software.
Okay. So now here is the environment of Neplan, as you can see, and now this is an empty project. Nothing is loaded. I have the possibility to go here and open existing projects or create new projects from scratch. Let's see first, if I open a project, then I can go and I can see here some projects that I was working with, my recent projects. Or I can go in the database, and then I can see all of my projects that I have here. Yes?
Anas, Srinath here. I think you should start with the EV model example.
Sorry, EV?
Yeah, the hosting capacity, the EV hosting capacity.
Okay. So as you see here, I see
one of the users have asked for that. Yeah.
Okay, very good. So these are my projects. Of course, in Neplan, you have a set of predefined examples, benchmark examples. There are many of them. And when you have the software, then you have access to all of these networks. For the time being, I will use this example. And this is this is tuned for a hosting capacity calculation as it was requested. And when I open this, as you can see, this is overlaid in a map. Can you please mute the microphone, because I have some. Thank you. And this network is overlaid on the geographical, let's say, map. Here is my feeding. Here I can see some feeding stations on the network, as you can see. And I see low voltage, and also medium voltage. The dashed is medium voltage. Anyway, I can have a look at my network. I can see here some houses. For example, this one, they have already some electric vehicles. I can double click here, and I can go and I can see my load. Of course, this represents the household. This is 8 kilowatt peak power. For this household, and I can, for example, this house doesn't have electric vehicle. Anyway, from now on, I can start, because here I have the complete model of this network. I can also see it I can also see like schematical representation of the network. Not only the geographical. Here you see the network in a geographical representation, but the same network, you can see it also in schematical representation. So this is my network, okay, that I have. And if I double click, for example, if I double click this transformer, I can see the parameters of the transformer, primary voltage, secondary voltage, rated power, and I can see if there is any regulation. Here it's not on load up change the transformer. And now I can run here a load flow. By running a load flow, I can, it's here, okay, I just run the load flow and then I can see my results. So if I go here, I can see the results in a single line diagram. So if I zoom in, I can see that the node at this point is 100.7% and the power is 24 kilowatt and reactive power is 9.4 kilowatt. And then I can go into the, of course, I can see it also here. I can see some messages. Immediately, I can see if I have some violations. Or I can go in the feasibility, and then I can see if I have violations here. The only thing I can see is angle delta limit, but of course, this is I can set it. If I go to load flow parameters, in loading limits, I can say, okay, make 5 degrees for angle delta, so he will not show me the angles, angle delta. Okay, now I see my network doesn't have any violation, and this is good. Now the question is, okay, we see in this case that only one house has electric vehicle. How much power can I actually connect in terms of electric vehicle? If I want to make this study, this is a study actually of the network. We have a tool here, among others, as you see, the tools I mentioned during the presentation. If I want to make a fault analysis, if I want to make a dynamic analysis, and so on. Among others, I have a tool called hosting capacity. This is in the distribution part. You see we have a split here. And I can go and I can select hosting capacity. And then I can go and tell him, look, now I want to find out how much power I can connect. I don't want to make the study for photovoltaic. I want to study for immobility. And I have the possibility to select to make the hosting capacity for individual locations if I concentrate only on this, for example, or if I want to find out in total how much immobility I can connect. And then, because we don't know in the future, we don't know the future of penetration, let's say, and we don't know how much power is going to be used. But what we can do is we can give some potential. So if I go here, I can see for every location, we have some potential for electric vehicles. You know, there are some sort of socioeconomic factors. If we are making the study in a rich neighborhood, probably we expect higher potential for electric vehicle penetration than if we are talking for a poor area where people cannot afford electric vehicles. Anyway, what we expect is we expect for every location, we expect some potential. If we don't have this potential, then we can use probabilities. Then we can give a distribution on how we expect that the electric vehicles are going to integrate it. So we can say we expect 2 kilowatt chargers to be 50% of the cases. We expect 5 kilowatt chargers at 40% of the cases, and so on. And here we can make our selection. So I can make it probability based, and then I can select here my candidate locations where I expect electric vehicles to be connected. You see, this is in low voltage network, and I have selected certain nodes as candidate nodes where I expect chargers to be connected. And then all I can do, all I need to do is I click the calculation, and then the software is making a Monte Carlo calculation by checking different sizes at different locations until we reach 100% of electric vehicle penetration. And when the Monte Carlo simulation is finished, then we can see the results. I can click, okay, now he finished, it's 100% completed. And then I can click the chart. And I can see, for example, what happens with the voltage. And I can see that very quickly, my voltage is dropping. You see, the more I increase the electric vehicle penetration, you see statistically my voltage is going down. I reach a point in 170 kilowatts of total penetration that all the voltages, all the scenarios that I tested, these dots are scenarios, all the scenarios that I tested are violating my voltage. Therefore, I cannot increase the power more than that in terms of voltage. And in terms of loading, I can see that I have more power. I can inject a little bit more power. Okay, I'm almost there at the same level. Again, you see in the beginning when I add electric vehicles, my power is more or less constant because I have also some generation which can absorb the. I have some photovoltaic generation which can absorb the extra power demand of electric vehicles. But then when I increase the penetration of electric vehicles, you see the loading starts to go up. And after a certain point, I observe that the loading is always above my 100% loading. And therefore here I will have always a problem. So I know for this network, I cannot make 200 kilowatt penetration of electric vehicles. Why? Because I will have overload and voltage problems. Another thing is I could see also for each individual location how much power I can connect. And in this case, I go and I say connection point power. Then I make this calculation, as you can see. And then he's telling me that at this certain location, you can connect maximum 37 kilowatts, no more, because if you connect more, you will have a problem. And then I can see it also with a heat map. For example, I can activate this one. And I can see it in my chart. Okay, here he's not updating it. Let me check. Okay, it is here. And then I can say, okay, show it as a background. All right, here there are some settings that I need to make the heat map in a better way. But anyway, you understand that I can make the heat map and then I can see my my results. I can deactivate it anytime I want. If I go to diagram properties, I say, for example, in the visualization, do not show the heat map or show the heat map, and so on. Of course, here for the study, there are many possibilities. What I can do here, I can include measurements. So if I go inside this load and I go in the scaling factors, I can see that I don't have measurements yet, but I can go, for example, and I can say for a time simulation, I can set my module in time simulation, and I go to options, and I tell him to use measurements, which I have previously imported. And now, if I go back to the load, and I go to the scaling factors, you see he's telling me that this load, this consumer, has actually measurements. Maybe they're coming from the smart meter, which is installed here for this household. And I can actually see the measurements of this house. See, like it is here. Of course, this is for 7 days, and this is for 1 day. I have a peak during the 12 o'clock hour, during morning, sorry, and then I have an afternoon peak for this load, and then I see the pattern repeated during the days. Maybe we have weekend differentiation and so on. These are measurements from a smart meter. Same way I can go also for a PV, and then I can see, and then I can observe if I have measurements for the PV. Okay, I have measurements for this PV. This is an inverter which sends back measurements to my to a system, and then I can tap to these measurements, and actually I can see that for these 7 days, this is my day profile for power from the photovoltaic. Of course, here you see I have some resolution which is defined by the parameters, or this is defined actually in the measurement itself, because if I go here in the measurement, if I go to the measurement table, I can see, for example, for the photovoltaic, I can see the table of measurements, and I can see that they are actually every 1 minute, as you can see. They measure, they make the inverter, he's making a measurement every 1 minute. Anyway, that was a short demo. I would like now to, unfortunately, we don't have time to see all the features, but I would like to give some time if there are some questions or if there are some things that you would like to see or ask. Hello.
Participants, good afternoon.
Good afternoon.
If you have any queries, you can type it down in the chat box, or you can simply unmute yourself and ask questions to us.
Hello. Hello. I am
Yes.
audible? Hello.
Yes, please.
Sir, myself, Professor Pardesi from HOD Electrical Engineering Department, Sanjeevani College of Engineering, Maharashtra. What is the cost of educational model of this software, and how many users we can going to get incorporated for this?
How many users for the research package? You can have maybe Trinan is more able to answer this question. Trinan, can you take over?
Yes. Sir.
Yes, sir. We offer this. Hello, this is Trinan, sir. We offer this license for educational institutions in various modes, and the price of the solution depends upon the mode which you're selecting, whether you are going for a cloud solution or for a server-based solution. So according to that and the number of modules that are required, so this will be changing. So we'll have a customized name.
Sir,
Yes,
we will take this commercial inquiries to ourselves.
Yeah, sure. So I think your team will be dealing with this. So please go ahead.
We will be.
And we'll take this question offline.
Yes, sir. I just request you to just look in the chat box and please answer the technical questions from the faculties.
There was a question about the IEEE fiber system modeling and all. So yes, so this we can do in some of the demo session, because in the interest of everyone who has already a bit of knowledge on this, we have carried out a generic presentation. But as you have seen the capability of the software, this with Neplan you can model unlimited number of buses. There's no limitation on the load flow capability. So fiber system can be very easily modeled, and also the lot of experiments which are there as a part of curriculums can be simulated very much easily. So we can have a one-to-one demo in case needed to demonstrate these capabilities to you. And GPS data for network loss calculation, yes, this can be used. Neplan has a very versatile integration with the GIS maps, which are called shapefiles. So you can directly import the GPS data, and in case you have the line data as well, we can model it. and you can calculate the network losses by performing the load flow calculations. And I think short circuit and load flow analysis, yes, these were shown by Panos in his demo, so that's okay. Free trial software link. Yes, this is possible for the universities, their university students. It is there, and you can also go, you can register yourself on the Neplan website, which we'll be sharing. And coming to the question, are there any models for technology like battery energy storage, interruptible loads in Neplan? I think the best model, Panos, it is we have shown this in the smart grid models, right?
Yes. Yes, we have, as you see here, we have several models. So if I go, for example, for DC and converter, then I can see that all the models that I can use. So we have, for example, DC photovoltaic, DC battery, AC flywheel, and so on. So if I drag it and I drop it in my network, then I can see the model of the battery, where I can specify, for example, the voltage set of the battery, or I can go to the dynamic analysis section where I can make more detailed modeling, let's say, for the battery, to select the battery technology, to select initial energy, discharge rate, charge rate, and so on. Depending, of course, the calculations that we intend to do, we can use energy storage. If we are interested about energy, we can simply use this model, energy storage, which is generic energy storage. And we can make, for example, initial maximum energy. This is the capacity of the battery, initial charging, state of charge. And then we can make discharge rate, charging rate, discharge rate, and efficiency. And then we can make the simulation for the battery. Of course, when we include storage in our network, we expect to have the time dimension, because for a steady state, for load flow calculation, a battery is nothing more than either a consumer or a computer, or yes, or a load or a generator.
Yeah. Coming to the next question, is there any demo copy available? Yes, we all can search. Just Google a term called Neplan 360. The demo version, once you register on that, there's the demo version access that will be given to you through your registered email ID. So that is possible. Coming to the next question by Supriya Sarkar, what is the difference between Neplan and PSCAD? PSCAD is a...
Trinath sir, sir, I
Yes,
request you to let me answer this question.
Yes, please. Yeah.
Because actually, first Dr. Vara Prasad sir asked this question, and this question is very important for the faculty's point of view. So I would like to answer this question on behalf. Is it okay?
Yeah, sure. Go ahead.
Yes, go ahead, please.
Yes. So Dr. Vara Prasad sir, Supriya madam, and many other faculties. My name is Sanket Pimprikar. I would be telling you the difference between Neplan and all the other power system software. Firstly, sir, the major difference is Neplan is a corporate corporate and industry software, and it is also used by the corporate industries as well. Not in India, but also in the other countries as well. It is present in over 100 countries. Then, second of all, Neplan is so beautifully created with bundles that it contains not only for education point of view but also research modules, as unlike by the other software. Other software, as you add the bundles and the module and the capabilities, cost increases.
I think we lost your voice there.
Yes, no, sir. Actually, I just told them the means benefits of having Neplan or other softwares. You will be taking the technical aspects of the Neplan over the other softwares.
Right.
Yes.
And one major advantage which I would like to mention is here for Neplan, one major thing which I would like to mention to everybody, that Hitachi ABB is not only the developer. We develop this. We use this for our own system studies for all the industries. So unlike other softwares where a software is taken and sold, we are not just resellers of the software. We are the implementers and preparing guys of this software. So the in-depth knowledge which sharing which happens through trainings is the value add which we give in this along with this software. Here, as I mentioned in the beginning of the presentation, we don't look for selling a software or something. We look for creating solutions along with the university. So that is the main distinguishing thing which I would like to mention. So we use this software for all the technical studies we perform for the industry, not only in India, we provide, but all over the world. Also, the European Union Neplan is used for the distribution system to transmission system modeling, and utilities are maintaining their entire databases on Neplan.
Yes.
Okay. So coming to the next question. When we go for a real-time study of power system. So real-time in the sense it is not like RTDS. RTDS kind of simulations not possible with Neplan. But then you have a SCADA interface. Those can be integrated with Neplan to an extent where you can use it for the fault finding studies and other protection studies. Can a model LV microgrid for fault detection? Yes, fault detection applies to any voltage level. So as long as it is a, you can mention voltage and represent a generator and a load, yes, it can be used. Can I model the microgrid for load frequency control with different renewable energy sources? Yes, sir, it can be done. Neplan has a very vast library of dynamic controls like governors, wind turbine controllers, and power system stabilizers, automatic voltage regulators, etc. So all the with the vast amount, other than the vast amount of regulators that are inbuilt, you also have a provision for having customized load block building, just like MATLAB. So you can build up almost any control diagram which you have within Neplan and try you can simulate the corresponding dynamics for the system which is modeled. Is the model parameter data available for inbuilt models in form data sheets or library? The beauty of this Neplan software is that all these things are stored within a file. So once you have an example file, you have all the data inbuilt. So that can be exported into all Excel or MS Office packages. So that is very much possible in the software. The cost of the regarding cost and all, Shiv has shared his email ID, so I think
Regarding
get in touch with them.
we have already given
Yes.
some mail IDs,
Yes.
venkatesh@india.co.in and shiv@indiasoft.co.in. Okay, so for the commercial, you can please put your queries on these email IDs and please go ahead, sir, with the question and answer.
The MPPT design for solar system. Yes.
Just a second, sir. All participants, feedback link will be shared in the chat box. So please be here. Without feedback, you will not be able to get a certificate. Okay. Go ahead, sir.
Yes. So then there is a question about MPPT design for solar system. So here you want to so with this MPPT design of solar system, you want to say you want to maximize the solar power output. Yes, those dynamic model can be kept provided you have the numerical model available with you. Neplan gives you two ways of building it. One is you can write it in the form of a program. It's called the customized MATLAB sort of building models, which you said. So the Simulink sort of models. So with those, you can build it. Kindly send me the PPT, Panos. Yes, sir. This copy can be shared with you.
Yes.
Multi-objective, yes, is possible. I believe you're saying this about the optimal power flow. So the multi-objectivity is like you can choose to minimize the losses or maximize the cost of or minimize the inverse, something like that. But I don't know what it is exactly. Will be multi-objective, but then you can minimize the losses and maximize the voltage regulations, etc.
I think this is the answer. For example, he means if you can combine different objective functions at the same time. So as you can see here, when I go to optimal power flow and I go to parameters and I go to objective function, I can select to add two objective functions at the same time, and then I can give weight for each objective function. So basically, I can add several objective functions in my list here. The only thing that I have to be careful is that if I optimize losses, which is the unit is megawatt, and then I optimize also cost, which the unit is a currency unit, for example, Indian rupee, then I need to be careful with when I add it in a multi-objective function scheme, because it might be that I will have a scaling problem. You know, if I have, for example, losses together with cost, maybe one will be in decimals and the other will be in millions. So I just need to be careful with the scale, and this can be done with the weight, let's say. But yes, this is possible to have multi-objective optimization.
Yes. Thank you, Panos. Thanks for that. And optimal power flow is available in Neplan. Yes, it is there. The module is there in Neplan, but I think for university licenses we have certain restriction on that. So we'll discuss in one-to-one, sir, as for the requirement. But yes, Neplan has a possibility of doing optimal power flow with a very exhaustive list of optimizations. You can do a financial analysis as well. Investment analysis module is also there to identify all the payback periods and everything. Can a comparative study for understanding basic difference between OPF and load flow analysis? I think the comparison can be done between the different variants which are there, which we can create. So Neplan gives you a very unique feature where you can create a tree kind of a structure where you can create multiple studies within a study, and you can display the results of all of them to compare on the screen itself. So yes, you can do a comparative study for the different things, but OPF is an objective function. So once the controls are set and you run the analysis, yes, you will be able to do the things.
Participants, feedback link is shared in the chat box. Please fill the feedback form. And those who still
there is another question,
ask us the question in the chat box, or they can simply unmute themselves and ask direct question to Trinath sir.
There was another question, can we perform simultaneous faults? Yes, Neplan gives a good provision to have simultaneous faults. We have also a module which the short circuit module also addresses the faults like having from one voltage level, phase 1 of one voltage level to the phase 2 of another voltage level. Such kind of special faults can also be created within Neplan. So you have a very flexible mechanism of creating these faults, and you can view all the results on the screen. Then there's a question about hybrid system with dynamic load is possible for microgrid. When we say dynamic load, yeah, Panos, go ahead.
Yes, dynamic load. I don't know exactly what the terminology means, but what we can have, for example, we can make a voltage dependence for the voltages, so we can have a zip model, or we can have exponential, or we can have IEEE generic, so we can make let's say voltage dependence for the loads. So as you see, we have adaptive load, time dependent load, exponential load, and so on. And basically this is included with a dynamic analysis. It makes sense when we are making dynamic analysis. I don't know if this is what the question is. If it's not, please clarify more.
Yeah, thank you, Panas. I think that was the thing. Dynamic load is the IEEE models and all they were mentioning about. And coming to the next question, shall we do analysis in FACTS devices? Yes, Neplan provides a variety of FACTS devices which can be modeled, and the extended Newton-Raphson method of Neplan includes the controls of all the HVDC and FACTS devices.
Yeah, so if you go here, for example, in let's say one port elements and filter a little bit let me filter a little bit. So you can see that we have models for SVC, for STATCOM, and so on. So I can bring, for example, an SVC here, and then I can see the reference for the SVC, the capacitive range reactive power, inductive range reactive power, and the slope. And if I have doubts about the model, then I can click help, and then I can see for SVC a description of the model and how it is modeled in Neplan. So you can see, for example, description of the model in the documentation, which is quite extended. You can see, you can learn also how the SVC is modeled and see more details about it. As you see, we have a capacitor and inductance, and then the controller regulates the inductance in order to choose between the areas to operate with a certain slope that we provide.
Yeah, and there was another question. Somebody mentioned that are there any training sessions offered? Yes, you can please get in touch with our IndiaSoft colleagues so that they can give you that we can provide trainings in various technical topics.
Thank you, Trinath sir. And feedback form is shared in the chat box. If you have any queries, you can still ask to the Trinath sir. And I would like to say thank you to Mr. Kontodimos for such a fantastic presentation on Neplan. And I would
Thank
like
you for the invitation and for the attention.
Arranging such a great session on such a short notice. So thank you all the participants who have been with us from the last 2 hours. Still, if you have any query, you can ask to us in the chat box, or you can simply unmute yourself and you can ask directly questions to the Trinath sir. And in future also, we are going to arrange these kinds of session more for you. So please stay tuned to us by the mail. We will share you the recording of this session as well as the PPTs and all the documents material with you. Okay, and please give us your valuable feedback to us. And the mail IDs are mentioned in the chat box. That is shiv@indiasoft.co.in and venkatesh@indiasoft.co.in.
Hello. Hello.
Yes, sir.
Hello. There is one suggestion, sir. Can I speak?
Yes, please.
Yes.
Whatever presentation you are given, you are trying to cover so many things within a very shortest time. So you can arrange some training sessions, either 1 hour or 2 hours, so in which you can show the exact demo how to utilize this software. Then it will be helpful for our academicians as well as other people joining the sessions.
Yes, I think this Trinath, I think you can take over this question. Huh?
Yeah. No, it was a suggestion. Thank you for the suggestion, sir. So today's agenda was to make those people familiar about the features that could be available and what all we can do using a simulation software. And yes, there can be a dedicated sessions pertaining to a certain analysis in which we can give in-depth understanding of the analysis and also how to use the software for the given type of analysis.
Yeah,
so that's what the training session which we can offer.
Yeah, yes. Of course, you can take either load flow or short circuit, any one example, and you can manage the session. So other people or new people can understand it very clearly and then they can suggest to their
Yeah.
management or the head of the departments to go for this type of software.
Definitely,
Definitely
sir. So we
exploring
will
lot of
we can
new
do that.
things.
Yes.
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 Yeah.
And just a remark, because here, for example, in many European and also in the US, such software like Neplan is an excellent companion for the undergraduate or postgraduate studies, especially for power systems, because what you can teach, for example, if a professor is teaching the load flow algorithm, where you have to solve a 3x3 system, then you can verify your results immediately in Neplan. So it's an excellent companion also for the undergraduate, for those PhD students or professors who are making the curriculum for the undergraduate as well.
Okay, thank you, sir, for taking our suggestion positively.
Thank you, Dipesh sir.
Yes, sir.
Any other queries? Faculties, if you have any other queries, please put you in the chat box or please unmute yourself and ask us the question.
Sir, is there any provision of supplying for one users or minimum 3 users?
Hello, ma'am. We have 25 users bundle with us currently, and means this is the bundle created for the education and as far as research purpose also.
Okay. Okay, sir. Thank you.
In case of a personal usage or a research usage, a demo version for the individual can be used, can be taken by registering yourself on Neplan website.
Okay.
And in case you have any specific need of you want it for a limited period, that is also possible.
Okay,
But
that's
we are
fine.
giving this as a pack. In case that is for individual needs. For universities, as he has mentioned, so this is available in certain bundles.
Okay, okay, sir. Thank you, sir.
Yes, and just to add on this, through the university, the research license, you have access to all modules, and with a big number of nodes that you can use for calculate. But if you are going to make it yourself, to make a student version, registering yourself in an Neplan on your own, then you are getting a student version which is limited. So if you want to make advanced research topics, it's better to stay with the university, let's say, access. Anyway, it will be 25 users. I think there will be a slot for you as well.
Sir, what is the price for this software with 25 users?
Sir, the mail IDs we will provide you. You please all your inquiries for the purchase. Please mail us.
Okay.
We will get back to you.
Okay, fine.
Email ID is provided in chat box.
Okay.
The only thing I will tell you here is that there is a vast difference in price between commercial use, utility environment, for example, and research. For research, we are giving special prices, which is very, very, very affordable, let's say, for the universities. But for commercial use, prices are different. Okay, it's a different category, let's say. But what you are getting is you are getting the research price, which is very, very attractive.
Fine, sir. Thank you.
Welcome.
Yes, sir. We will be giving them the idea about the same. And for any commercial inquiries, faculties, mail IDs are provided. You please put your inquiries and mail to us. We will get back to you. Thank you.
Participants, any queries? So if you have any queries, otherwise in next 2 to 3 minutes, we will wrap up our session. If you have still any queries, you can ask us in the chat box, or you can simply unmute yourself and ask queries. If you have any technical doubts or any commercial For commercial, you can simply type a mail on shiv@indiasoft.co.in or venkatesh@indiasoft.co.in.
Okay.
Srinath, sir? Yeah, is there any?
Yeah.
Is there anyone having query? Okay,
No,
I think
I don't see any further questions. I just saw the feedback links and the contact details.
So, sir, I think we should wrap up the session.
Yes.
So all the
thank you
participants
everyone
who
for
haven't
joining.
filled feedback, please go and fill the feedback. According to that, you will get your certificates. So please fill the feedback. Without that, you will not able to get that.
And participants on the WhatsApp group, we will share the this session's recorded link to you. Okay, and please like and subscribe our YouTube channel also. And more the videos we will put on our YouTube channel also. So link will be given on the WhatsApp group for this recorded session. Okay, thank you, Trinath sir. Thank you, Mr. Kontodimos from the Switzerland for the nice presentation. Thank you, everyone.
Thank you. Thank you very much for the invitation, and it was very interesting. And I think this will benefit any institution will get this technology. Okay, from my side, this is all I had to say. Thank you, everyone, and I wish you all the best. Bye bye from me.